Hello friends, and in this lecture we'll discuss about the properties 2. In the Laplace transform continue, properties 2. Properties number 2. So what is property number 2? If L of f of t is equal to a bar of s is already is given, then t to the power of n f of t. If somebody asks you f of t, which you already know, and they given multiple of t to the power of n, so minus 1 to the power of n is how many power is given? You differentiate this a bar of s how many times? N number of times with respect to x. This is your Laplace transform of t to the power n into f of t, which means if somebody is given find the Laplace of sine of 2t, this which is already sine 2t Laplace is what? 2 by s square plus 4. But somebody asks you find the Laplace of t square into sine of 2t. So what you have to do, you have to apply this formula. Minus 1 to the power of n is how much here? 2. You have to differentiate how many times? 2 times with respect to x. Which one? Whatever the Laplace of your f of t. F of t is what? Sine of 2t, and sine of t to Laplace is a bar of s, and that is your 2 by s square plus 4. So this 2 by s square plus 4 will differentiate 2 times with respect to s. So minus 1 to the power 2 is 1, and if I will do the one time differentiation, I will get it here 2 by s square plus 1, this is whole square, minus 1 by s square plus whole square into 2s. Okay, so once again if we differentiate this constant term, I will take outside, minus 1 by 4, and I will get it s by s square plus 4 whole square, and the differentiation is u by v differentiation, this whole square into, this is 1 v into du by dx minus u into 2s square plus 4 into 2s divided by s square plus 4 whole square, that is your 4. So we can write it here minus 4 s square plus 4 whole square minus, this is your 4 s square into s square plus 4 by s square plus 4 to the power of 4. This is your Laplace transform of t square sine of 2t. You want to further simplify, you can simplify it, otherwise you can stop there. So next problem based on the properties 2 is, if we given find the Laplace of t into cos of 3t. So t is multiple here, so we have to consider this is property number 2, and property number 2, if t is the multiple, so you have to find the Laplace of this first f of t, and f of t Laplace is cos 3t, Laplace is s by s square plus 9. And when you are finding with the Laplace of t into f of t, the formula is minus 1 to the power of n, and that n is here depend upon this power, and differentiate this a bar of s how many times? N number of times. So here the Laplace is t into cos of 3t, so t into cos of 3t, so minus 1 to the power of n is here 1. You have to differentiate how many times? 1 times with respect to s. Which functions you have to differentiate? Laplace of this cos of 3t, which already we find here s by s square plus 9. So we can find the minus 1 to the power is negative numbers, and here u by v, so v into du by ds is 1 minus s, this differentiation is 2s divided by s square plus 9 whole square. So further you can simplify here, s square plus 9 minus 2s square by s square plus 9 whole square, and you can write it here 9 minus s square divided by s square plus 9 whole square. So this is your Laplace transform of t into cos of 3t. Thank you. Now property number 3. Let's see the property number 3. So in this property number 3, if f of t, Laplace of f of t is equal to a bar of s, already we know, then somebody find the Laplace of f of t by t is given. So you just integrate a bar of s with respect to ts from your s to infinity. Okay, so example here, consider if given find the Laplace of sine of t by t. So you know the Laplace of sine of t. What is the Laplace of sine of t? 1 by s square plus 1. So when you are finding the Laplace of sine of t by t, this sine of t divided by t, yeah, so you can integrate this sine of t Laplace is 1 by s square plus 1. You have to integrate this s to infinity with respect to ts. So 1 by s square plus 1, what you can write integration tan inverse of s, and you can put these values from s to infinity. You can put the upper minus lower here, tan inverse of infinity minus tan inverse of s. Tan inverse of infinity is pi by 2 minus tan inverse of s. So this is the property number 3. So what is property number 3? Laplace of f of t is equal to a bar of s, if already we know, and if somebody asks find the Laplace of this f of t divided by t, so whatever in the denominator is given, you find the Laplace of that terms and integrate from s to infinity with respect to ds. Okay, so we will see the example for this property number 3. So consider if questions is given, find the Laplace of cos of at minus cos of bt divided by t. So this is which type of property? Property number 3, because if given f of t divided by t, so you have to consider as a property number 3. If Laplace is given, property number 3, if f of t divided by t. So what is f of t here? F of t is here cos of at minus cos of bt. You have to find the Laplace of this f of t. So f of t Laplace is cos of at Laplace is your s by s square plus a square minus cos of bt Laplace is s by s square plus b square. So whenever you are finding for the Laplace of cos of at minus cos of bt by t, so we have to integrate from s to infinity. Which term? The Laplace of these terms. Laplace of this term is what? Your this s by s square plus a square minus s by s square plus b square with respect to ds. So how will you integration of s square, s by s square plus a square will you find here? Also separate, and I will use directly from here. So you can consider t is equal to log of, you can consider t is equal to s square plus a square, and you can write dt by ds is equal to your 2s. So by the substitution method you can apply here s as it is only, this is t, and ds is equal to dt by 2s. This s cancel, so you will get it 1 by 2, and 1 by t integration is log of t. So 1 by 2 log of this t values is s square plus a square. So this will integration will get it if you know the substitution which you were studied in the PUC year 12th. So we can do by on. So here we can write this properties, the integration formulas is 1 by 2 log of x square plus a square. Similarly, I can write it here from 1 by 2 into log of s square plus b square from s to infinity. Okay, so here 1 by 2, log of 1 by 2 is common. Log of m minus n, I can write log of n divided by n. This is the properties also for the log s to infinity. If we infinity we put, so log, if s tends to infinity, this will come value is 0. So we'll get it 1 by 2, 0 minus s, if we substitute, we'll get it here log of s square plus a square by s square plus b square. So after that we can reverse it, this one, because minus is there, and we can reverse it and we can find the log of x square plus b square divided by s square. I will write it here. We can write it 1 by 2 into log of s square plus b square by s square plus a square. Further, if you want to simplify, you can write square root is log of a square root of s square plus b square by s square plus a square. So this is your Laplace Laplace transform of cos of at minus cos of dt. Similarly, if given questions here, next question, if given, find the Laplace of 1 minus cos of at by t. So how will you find? F of t is here 1 minus cos of at. How will you find the Laplace of this? 1 Laplace is 1 by s minus cos of at Laplace is s by s square plus a square. So now if you find the Laplace of 1 minus cos of at by t, we can rewrite here integration of s to infinity this one, 1 by s minus s by s square plus a square with respect to ds. So log x difference, this 1 by s integration is your 1 log of s, and minus this integration is your log of s square plus a square from s to infinity. So we can write log of s by s square plus a square from s to infinity. Infinity, if you put, it comes 0, and if you 0 minus log of s by s square plus a square. So now you can reverse it. If a minus is there here, which means log of 1 minus log of b given. So you can reverse it here. We can rewrite for the last questions like s square plus a square by s. Okay, so this is the property number 3. In the next lecture we'll see the property number 4, and we'll go to the convolution theorems, unit step functions, and remaining portion of this Laplace transform.